Well, hello again. And we are going to be jumping right into the next part of chapter 4, which gets into multiplying and dividing sign fractions. Now, you're probably wondering why we're not doing adding and subtracting first, but it turns out that multiplying and dividing is a little bit easier. So we're going to start with that. And the rule for multiplying is very, very quick because all you're doing is if you have one fraction and you're multiplying it by another fraction, you just multiply straight across. So you multiply the tops and you multiply the bottoms, and that's it. Now, obviously, you do want to reduce those fractions down to lowest terms when possible, but you're just multiplying straight across. Now, there are some little tricks that we're going to see as to how we can simplify the process, but essentially, this is it. Now, the only other thing I'll mention is when they try to do it in a more applied fashion, they'll use the word of a lot to describe multiplication. Now, that's a lot of the time, but not all of the time. So you do got to be a little bit careful with some of the wordings that they'll use. But let's jump right in and see how this works. So we got write the answer in lowest terms. So we got 3/8 times 5 over 11. Now, if we multiply straight across, we're going to get 15 over 88. Now, can we reduce this down? It turns out that there's no common factors between 15 and 88, so we're done. That is the answer. What about this next one? Well, we can do the same thing. We can multiply straight across. So we got 2 times 6, which is 12. We got 3 times 7, which is 21. So now, is that in lowest terms? 12 over 21. A little hard to see, but let me try to write a little darker. It turns out for this one, though, there is a common factor that we can divide out. So 3 goes into both of those. So if we divide the 3 out, we're going to end up with 4 over 7. So 4 over 7 would be in lowest terms. Now, how could we have gotten rid of that common factor a little bit earlier in the problem? And it turns out that, well, we can reduce vertically, but we can also reduce diagonally. So if there's a common factor diagonally, you can divide it out there versus at the end of the problem. So in this case, had we divided out that common factor first, you can see now that 2 times 2, it bypasses to get you to the 4. 1 times 7 bypasses to get to the 7. So it's a nice optional way to lessen your work on the front end versus doing the breaking down at the end of the problem. So let's try that on the next one. So we got negative 15 over 24 times 8 over 25. So looking diagonally, we can see that we have some common factors. So 5 goes into both of those. So we can say 5 goes in 3 times there. And on this one, we got 5 goes in 5 times there. The other direction, 8 and 24 have a common factor. 8 goes into both. So we can divide out the 8, and we got that. Now, looking vertically, remember, we can reduce vertically as well. So right now we can see that 3 goes into both of those 3's. So we can cancel those out as well. So a lot of reducing that we can do right on the front end because they're smaller numbers. It's easier to see those common factors. But now when we multiply across, we got the 1 times the 1, which is 1. We got the 1 and the 5, which gives you the 5. And the only other thing you got to remember is when those fractions have signs in front of them. Sometimes the answer is positive, sometimes the answer is negative. What can we say about this one? Well, we got a negative and we got a positive. So the answer better be a negative 1/5. So not too terrible, hopefully. Let's keep going. So we got 11 and 33, which 11 goes into both of those. And what about 14 and 21? Yeah, 7 goes in. 7 goes into 14 twice. 7 goes into 21 3 times. So we've reduced diagonally as much as we can. We can't reduce vertically at all. So now we can multiply straight across. So is the answer going to be positive or negative though? In this case, it better be positive. So yeah, so we got to have positive 2 over positive 9. So 2/9 for that. Okay. Now for the next one, we really don't have two fractions, at least not yet. So 6 over 35 times 5. But we can make this into a fraction if we just put the 5 over 1. So what you don't want to do is multiply the top by 5 and the bottom by 5. That is not what is meant by this. It's 5 over 1. So now we can do a little cross canceling between the 5 and the 35. So 5 goes into itself once, goes into 35 7 times. So now when you multiply across, we just end up with 6/7. Done. All right. So you thought letters were done? Well, they're back. Letters still are going to be part of these problems. So, but they behave the same way common factors do. If we can recognize a common factor, we can cancel it out. So that's what we can do here. The x's are going to cancel. And there's nothing else that can cancel diagonally or vertically. So we can multiply straight across. So 3 times the 5 is 15. 4 times the y is 4y. Now, we have an improper fraction here. We haven't discussed how to take care of those yet. And if you already know, great, but don't worry about it when you have variables in there. So when you have those letters, don't worry about trying to make it look pretty. It's okay if it's lopsided. We'll take care of it later on, maybe. But for now, just leave it alone. All right, let's try a couple more, then we'll stop the video. So we got a couple more with letters in them. So let's see how those work. All right, so we got 6x over 25, 15 over 12x to the second power. Now we want to be careful because those exponents, we want to make sure we interpret those correctly. So what I would do is I would just rewrite this as 12 times x, because now we can see that one of those x's is going to go away. So we can cancel out one of the x's, and that's it. So we're gonna have one x left on the bottom, but we can do some canceling with the numbers as well. So the 6 cancels with the 12, goes in twice, and we got 5s that will go into those. So we got a 3 and a 5. So what's that going to give you for an answer? What do you think? Well, on the top we're going to get just a 3. On the bottom we got 5 times the 2, which is 10, and don't forget the x. Now, if you're in the habit of making fractions with a diagonal slash, I would get out of that habit. That is always a way you can make mistakes if you're not careful where you put those letters. Sometimes the letters are on the bottom versus on the top, so it just gets confusing when it's a diagonal slash for your fraction. Try to use a horizontal slash. So, all right, one more. Well, we got x's on the tops, so let's do the same thing we did over here and then just expand it out. So we got rid of those for now. Can we cancel diagonally anywhere? Well, you bet. We got the 3's can cancel out, and then the 2 and the 8 will cancel out as well. So what are we left with? Well, we can't really do anything with the x's because they're all on the top. They're not diagonally. They're not one on top of the other. So we're going to have to just squish them all together. So how many x's do we got? 1, 2, 3, 4 of them. So that's going to mean we have x to the 4th power on the top, and we got those 1s now. So if we want to put a 1 in front, we can, but remember that's not a requirement. On the bottom, we just got the 3 and the 4, so that's 12. So if you wanted to write your answer that way, I would take it, but we don't need the 1. So we can just leave it out and just say x to the 4th over 12. And that would be our answer. Okay, so let's stop there and we'll pick up dividing in the next video. See you in a minute.